Okay, we are continuing on with Taylor polynomials. And we're given another example here. So suppose that g is a function which has continuous derivatives and that g of 2 equals 3, g of prime of 2 equals -4, g double prime is 7, triple prime is -5. Write the Taylor polynomial of degree 3 for g centered at 2. Oh gosh, this is such a great problem because it really is kind of already laid out for us, right? So g of 2 is 3, prime of 2 is -4, double prime of 2 is 7, triple prime of 2 is -5, okay? And we want to write a degree of 3 with g centered at 2. So let's call our Taylor polynomial t sub 3 of x is equal to, well, our f of x at 2 is going to be 3 minus 4 times x minus 2 plus 7 over 2 factorial, that's a 7, times x minus 2 squared minus 5 over 3 factorial times x minus 2 cubed. And that was it. That's all we were asked to do. So we wrote a Taylor polynomial. Great. All right. Another example. Use a third degree Taylor approximation of e to the x for x near 0 to find the limit as x approaches 0 of e to the x minus 1 over 2 to the x. Then compare it to the actual limit at 0. Is this surprising? Why or why not? Okay, well, the first thing we have to do is write this Taylor approximation. So it's centered at 0. Oops, where am I at here? Yep, centered at 0, so c equals 0. So f of x equal to the e to the x. Well, the nice thing here, third degree, so we're going to go to 3. And guess what? All of our derivatives are the same. Man, life is good on Easy Street. So then we want to find 0, 1. They're all going to be 1, right? So just for the sake of consistency. Okay, so we've got all of these. So now we can actually write our Taylor approximation. So I'll do t again. So t sub 3 of x is equal to, and remember, I should write here, e to the x is approximately, right? Approximately t sub 3 of the x, which is actually equal to, we're going to have 1 plus 1 times x minus 0 plus 1 over 2 factorial times x minus 0 squared plus 1 over 3 factorial times x minus 0 cubed. And I can rewrite this, so I've got 1 plus x squared over 2 factorial plus x cubed over 3 factorial. That's my approximation of e to the x. Okay, so e to the x is approximately that. Nice, cute and sweet. All right, so we want to use this to find our limit. Okay, so let's take this information. We're going to find the limit as x approaches 0 of e to the x minus 1 over 2 to the x. Okay, that's approximately the limit as x approaches 0 of this, because we're going to replace this with e to the x. So 1 plus x squared over 2 factorial plus x cubed over 3 factorial minus 1 over 2x. Okay, so if I'm looking at that, these are going to cancel out. So this is going to equal, I can use equal sign now because I'm not approximating anymore. The limit as x approaches 0 of x plus x squared over 2 factorial plus x cubed over 3 factorial over 2x. Okay, and as x approaches 0, this is going to become 0, this is going to become 0, and we're just going to be left with our, these are going to cancel out, we're going to be left with our coefficients, so this is going to be equal to 1/2. Now, let's actually, we take note of that, let's compare it to the actual limit at 0, okay? So the actual limit as x approaches 0 of e to the x minus 1 over 2x. As x approaches 0, we're going to get 1 minus 1 over 0, so we can't do that. So we can do L'Hopital's. So this is going to be the limit as x approaches 0 of e to the x over 2. E to the 0 is 1 over 2 is equal to 1/2. That was much easier, but look it. These are the same. Is that surprising? It should not be, because our Taylor approximation should be very, very similar to the function itself. All right? Let's do another example. Given that p sub 2 of x equals a plus bx plus cx squared is the second degree Taylor polynomial for f about x equals 0, what can you say about the signs of a, b, and c if f has the graph pictured? Oh gosh, justify your answer. Well, it would probably help if I actually had this picture, right? All right, I'm going to draw it out here. So we've got this graph, and it looks like this. I just forgot to draw it. Okay, so we've got this graph. If you look at this, f of x is approximately p sub 2 of x, right? So, and p sub 2 of x is equal to a plus bx plus cx squared, okay? So our a value, if we were looking at this as a Taylor polynomial, is going to be f, the 0 derivative of f at 0 over 0 factorial. And this b is going to be f prime, f prime of 0 over 1 factorial. And c is going to be f double prime of 0 over 2 factorial. These are our coefficients, right? So coefficients here, right? And actually what I want you to think of here is, what do these represent? Well, this is our 0 derivative, which is just the function itself. This is our first derivative. This is our second derivative, right? So if you have these, you can kind of look, well, what's a going to be? A is just going to be our y value. Oh gosh, that's a stupid emergency alert. Ugh, sorry, students. A is going to be our y value. B is going to be our slope value. And c is going to be our concavity. Okay? So if we're looking at that, well, where is our y value? Our y value is up here, so a is greater than 0. We can say that about a. B is our slope. Our slope is what? Positive, so b is greater than 0. We can say that. And what about our concavity? Well, this is concave down, so we can say that c is less than 0. Okay? Not too difficult. Just got to apply what we know before. Okay? And finally, sometimes we can use Maclaurin polynomials to approximate functions without having to derive them using Taylor's theorem, but rather by modifying existing polynomials. Now, I know for a fact that this has been on past AP exams, so I definitely want to go through it. So we're asked to list the first 4 non-zero terms of the Maclaurin polynomials for sine of x, cosine of x, and e to the x. Then we're going to find the following. Well, guess what? We've actually already found sine of x a few pages ago. Where is it at? That was the first page. We actually found the approximation for sine of x. We already did that, so I'm just going to write that down. So sine of x is approximately x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. Okay? And cosine is just going to be the derivative of sine. I think you can probably hopefully kind of see that it's going to just fill in those gaps there, right? Sine is like fills in the gaps of cosine, or and vice versa. So cosine of x is approximately 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. All right? So these are the first 4 terms, And then e to the x is approximately, and I think we did this one as well somewhere. Yeah, we did it back here on the page before. E to the x is approximately 1 plus x squared over 2 factorial plus x to the 4th. No, plus x cubed. What am I saying? Plus x cubed. Don't miss anything with e to the x. All right? So we're going to use these 3 to actually find these following Maclaurin polynomials, okay? So these are the Maclaurin polynomials for sine, cosine, and e to the x, which I would say memorizing is a good idea. And then we're going to use it for sine of 2x, x cosine of x, and for e to the x squared. So let's actually start with sine of 2x. Well, sine of 2x, g of x is equal to sine of 2x. So g of x is equal to sine of 2x. I'll write that here. Equals sine of 2x, which is approximately. Now, any time that I have an x, I'm now going to replace it with a 2x. So it's approximately 2x minus 2x cubed over 3 factorial plus 2x to the 5th over 5 factorial minus 2x to the 7th over 7 factorial. And if I want to, I could expand this out, and that's actually equal to 2x minus 8x cubed over 3 factorial plus 32x to the 5th over 5 factorial minus 128x to the 7th over 7 factorial. Okay, simple, easy. All right, let's do this next one, x cosine of x. Hopefully I can see, you can see that in there still. X cosine of x. Well, if cosine of x is just 1 minus x squared, this all I have to do now is multiply everything by x, right? So if g of x is equal to x cosine of x, then that's approximately, I'm going to multiply every single term by x. So I'm going to get x minus x cubed over 2 factorial plus x to the 5th over 4 factorial minus x to the 7th over 6 factorial. All right, there's our approximation. And finally, we have here g to the x equals 4e to the x squared, and we want to find the approximation of that using e. All right, so 1 plus x squared over 2 factorial minus x cubed over 3 factorial. Kind of zoom out here so hopefully you can see it all. Get them all in there. A little more, a little more. Okay, so let's do our x squared first. So e to the x squared is approximately, instead of an x, every time we get x, I'm going to put x squared. So we're going to have 1 plus x squared plus x to the 4th over 2 factorial plus x to the 6th over 3 factorial, right? So this would be, maybe I should rewrite this. I will, just to show you how this kind of comes out. 1 plus x squared, here we go, plus x squared plus x squared. I'm going to pause for a second. Okay, so e to the x squared is approximately 1 plus x squared plus x squared squared over 2 factorial plus x squared cubed over 3 factorial. And that's, of course, equal to 1 plus x squared plus x to the 4th over 2 factorial plus x to the 6th over 3 factorial. Okay, so we've got that. Now we need to write our 4e to the x squared. It's just going to be this times 4. So that's going to be approximately 4 plus 4x squared plus 4x to the 4th over 2 factorial plus 4x to the 6th over 3 factorial. If I want to, I can keep simplifying this. So this would be equal to 4 plus 4x squared plus 2x to the 4th plus 2/3 x to the 6th. But really, if I was writing this on the AP exam, I would stop here because simplifying it's just a waste of my time. All right? So that's it. That's Taylor and Maclaurin polynomials and approximation and how they're used to actually approximate other more complicated functions. Leave any questions in the comments, and I hope to see you soon. Bye.